Hey folks, how's it going? It's Mr. Murray coming to you with a do now. This one is for Course 1 Honors, and here we are in what I believe is the 12th week of the school closure. Yeah, 3 months. So we're getting ready to wind down. We're going to begin this week by winding down our probability unit. And then we're going to move into a mini unit on regression. Very exciting way to end the year. So here we go. In Dubba Clubba, you draw 2 cards from the deck without replacement. Extremely important. If only one of the cards is a club, you win. If both cards are clubs, you win big. For the purposes of this problem, assume that each question you start over. So the 2 cards, you're starting from a brand new deck for each of the following 4 questions. So first, find the probability the first card is a club. Find the probability the second card is a club. Find the probability that only one of the cards is a club. And then find the probability that both cards are clubs. All right, so please pause the video, find these 4 probabilities, and when you're ready, unpause, and you can see what I got. All right, so probability. The first card is a club. So, 2 cards drawn. The first card, there are 13 cards I'm allowed to draw out of 52 because there are 13 clubs and 52 cards in the deck. Okay, card gets dealt. Now I'm down to 51. Second card does not matter. Only the first card had to be a club. So we got a 1 in 4 chance. Okay, probability the second card is a club. So the first card didn't matter. Right? Now, so we just want to know the probability of the second one. So 1 card gets dealt. First card doesn't matter. Now, basically what happens here, it depends. If the first card was a club, then there's only 12 cards left. So we're going to assume that the first card was not a club. We said I only want to know that the second card was a club. That might have been a question you had. So I'm thinking 13 out of 51. And that is actually slightly higher than the 1 out of 4 probability, but it's not quite 1 out of 4. All right, probability of only 1 club, which means I draw a club. Now I go down to 51. Now, of the 2 cards, only one of them is a club. So, how many cards could I now draw? Well, there's 51 cards in the deck. Assuming I drew a club already, how many other cards are left in the deck? Well, I can't draw another club, right? So there's 51 cards. There's 12 clubs left. So that's what I get. Okay? Probability that, so this is B, A, C, both cards clubs. So I get my 13 over 52. That gets dealt. And then my 12 over 51. Both cards are clubs. Because there's 12 cards left. 12 clubs left. 51 total cards left. Okay, so hopefully you're able to get this right. Please keep in mind that I'm actually okay with you leaving it in this form. But also please keep in mind there will be a mini Google form assessment sometime this week covering probability. So please be on the lookout for review and that quiz coming up. Just a Google form assessment to give you a little bit of closure and see where you're at. Best of luck, folks. Don't forget to love math. And remember, you can do it.